Hello, wonderful people. My name is Rehan. I'm 14 years old. I'm going to 8th grade and I'm also a robotics student. Today, I'm going to tell you on how Airbus manufactures its aircrafts. So let's jump into the presentation. These are the topics that I'll be covering today. So let's jump to the first one. First, I'm going to tell you the introduction to Airbus. Airbus started in 1970 in Europe to compete with American plane makers like Boeing. Its first plane, the A300, flew in 1972 and was the world's first twin-engine wide-body jet, meaning it had two engines. In 1987, Airbus launched the A320 with fly-by-wire technology, making flying safer and easier. By 2000, Airbus became a single company called the Airbus SAS. So, what is Airbus? Well, Airbus is a European company that designs and builds small airplanes like helicopters and spacecraft. It is one of the biggest aircraft makers in the world. So, where are its headquarters and major products? Well, the Airbus HQ in Toulouse is in France. The major products are the A320, which is a small flight, and the A350, which is long distance traveling flight. And where are the global presences? So, it has major factories all over the world. In Europe, for example, France, Germany, and the UK. And also a big company in Hamburg, which is not far from where I live, for example, 200 kilometers away. Airbus also has assembly plants facilities worldwide, including the USA, Alabama, and China, Tennessee. So this is the A320, the A350, and the headquarters in Toulouse, and the factory Airbus in Hamburg. Now the types of Airbus passenger aircrafts. The A320, this type is mostly used as a domestic flight and small international travel, for example, Frankfurt to Munich. Max amount of people which can fit in it is 195 and max speed is 871 km per hour. The A320, A350 is very small and can use also for small international travels, for example, till Frankfurt till Paris. And now coming to the A350. This aircraft is used for long and international travels, and it's also very fuel efficient, meaning it doesn't take much fuel. For example, it can travel from Frankfurt till Chennai, and max amount of people which can fit in it is 410 and can go till 145 km per hour. A380, this product is used for very long travels. It has a double deck and not very fuel efficient. But for example, a distance is Frankfurt till Singapore. Max amount of people which can fit in it is 850 and it can travel 1020 km per hour. Now coming to the major components of an aircraft. So this here, it is not labeled, it's called the nose. This cuts through air and makes sure the plane can move forward. The cockpit. The cockpit is where the pilot sits and controls the plane. Now coming to the fuselage. This is where the people sit and also the cargo goes. And the slats, this changed the lift, meaning whenever it needs to go up and down, so it helped. The spoiler, well, the spoiler is the thing which can help for landing, and the aileron, this changes role and rotates the body when it needs to. This is the flap, which change and create lift to drag, which helps the plane fly. And the rudder, this changes the view on the nose, so when it needs to go up and down. And the vertical stabilizer, this helps the plane for nose going to up and down, and the horizontal from left to right. So the wings help the flight to fly, and the jet engine, this is important to create the thrust. From there, the fuel burns and makes the thrust so the plane can fly. And now the materials which are used in a plane. So step one, making the structure and the frame skeleton. The materials which are used in there are called aluminum alloys. So the aluminum is usually mixed with other metals like copper or zinc. It's strong and very lightweight and doesn't rust easily. And step two is adding skin, the outer body. This is the smooth outer surface that covers the skeleton, and it's like the skin of the plane. So the materials they used are called carbon fiber composites. So it's super light and very strong, often used in the wings, tail, and parts of the fuselage. So this also helps reduce the plane's weight. So the step three is called engine parts. So the engine gets super hot and needs special materials that can handle the heat and the stress. So the material which they use is called titanium. So this is a very strong and heat resistant metal and doesn't corrode. So this is used in engine blades and important hard parts. Step four is the inside the plane cabin, seats and etc. So here they use lightweight but safe and fire-resistant materials. So now I'm coming to the vendors and details. So from here, I got the help from my dad, and the sources are ChatGPT. So airframe and structure, for example, here, the Spirit Aero Systems, which create the fuselage, for example, these are from the USA and they supply to Airbus. For engines, Rolls-Royce is a huge company and also Pratt and Whitney from the USA and the Rolls-Royce from UK. So Tala, and in the electronics, Thales is a France company, and its flight control system and and it also gives entertainment. And Honeywell, well, Honeywell is for the power units and provides avionics. So this means it provides all the electronic system it needs to for the plane and the cockpit. The landing gear, for example, the Saffron landing, which I already told, this provides also for like the landing gears and the wheels which needs to go. And in the interior, well, there is also Stelia Aerospace, again from France. This provides cabin seatings, for example, the seats and everything, and the materials. So the material composites like the metals and everything, the hexel and Torre are very important for Airbus. And software, well, Palais is, like I already told, flight control system and in flight entertainment. So these are important. And the Lufthansa system from Germany is also a huge role for Airbus. So this gives, again, very much of software and digital systems which they need to have. Engineering and design services. So for example, the TCS this is a software service from India, and the HCL, this is simulation. This can give for the this can give, like, for example, the simulation of everything in the plane to the computers. Now coming to the manufacturing process. So the designing and engineering. So first, the Airbus crafts thinks about the digital 3D model. So they make it in CAD, called computer aided design software. This helps them to visualize every part, how the aircraft will look, and what it's made of. So then they test it and they use it. They use a 3D printer to print it out, and they put it in wind tunnels to see if the wind is going to the wings correctly or not. If there are any changes, they do it. So now coming to the parts and manufacturing. So the airplane is made in different parts across Europe. For example, wings are made in the UK Welsh. The fuselage is the main body, which is made in Germany. The cockpit, where pilots sit, is made in France. The tail, made in Spain. And each part from the different countries will be transported to the Airbus Beluga, which is like a whale, as you can see in the image. That's what it looks like. And then the final assembly. So most of the final assembly happens in Toulouse, France. So here engineers and robots work together to put all the forms of the wings and the fuselage together, and then they put the wiring and testing system. So the electrical wiring for lights and instrument for and everything, the hydraulic system, which controls like landing gear and the flaps, and of course the passenger cabin. And number six, now coming to the testing of the aircraft. So number one, there's a ground test. This happens before the aircraft moves anywhere. They check if the brakes are working correctly, if the power is turning on, or they also check special power levels. And number two is the taxi test. Now the plane starts slowly moving on the ground. This is called taxiing on the runway. So when it's ready to take off, it goes into the speed which it needs to, and then starts taking off. Then comes the test flights. Now it's time to fly. So pilots take the aircraft into the air to test it for real. So they check if it's smoothly on and can go in different altitudes, and make sure the cabin pressure is okay so the passengers can breathe, and check balance and stability. So is the plane balanced or not, and everything. So these flights are done by test pilots and not airline pilots. So test pilots are pilots from Airbus itself and not from airlines. So now they also do a safety checklist. Of course, they do it twice before handing over the aircraft to the airline. And now the fuel system and performance. So jet fuel is used to make the planes fly. So it's mostly kerosene based, and it's not like petrol or gasoline. So this is much more expensive than those. So, and it doesn't even burn easily. So the fuel is called Jet A or Jet A1, and it doesn't freeze much easily because it can stand up till minus 50 degrees Celsius. And it's also very less flammable than gasoline. But where is the fuel stored? It's mainly stored in the wings of the aircraft. So this can make the plane balance while flying and doesn't take space in the body. So how does the fuel make it to the engines? Well, there are electric pumps which push the fuel through pipes to the engines. Valves and filters clean the control to the fuel flow. Fuel reaches the engines, burns, and creates this thrust, which helps the plane move. And now, how much fuel is needed for a short and long flight? For a short flight for a small in the country, 7,500 to 8,500 liters. And for a long travel, for example, from Frankfurt to Mumbai, they use 90,000 till 95,000 liters. But of course, a plane can also use more fuel depending on its weight. So if the flight is too full, it needs, of course, more fuel to create the thrust so it can move forward and take off, which you'll understand now because I'm going to tell you how an aircraft flies. When a plane like the Airbus A320, A350, or A380 gets ready to take off, it uses fuel stored mainly in its wings. So this fuel moves through the pipes, which I said, to the engines. For example, like the A320 has two engines under its wings. These engines pull in air, mix it with the fuel, and then burn it. These hot gases that come out, then they push the plane forward. This is called thrust. As the plane speeds up on the runway, about 250 kilometers per hour for the A320, air flows over the wings. These wings are shaped in the air so the pressure of the air will be more on the top than in the bottom. So this difference creates a lift, and this lift will rise the plane, and then so it can start flying. But like I said, if the plane has more weight, it needs more thrust to take off. For the A350, they need 280 kilometers, and for the A380, 310 kilometers maximum. Now, then now comes the flight controller and software. So this is so this so converts pilot inputs to electronic signals for safe stabilization and flying with protection. So this is mostly made by Tails and Saffron. So and also by Airbus itself. Then comes the flight management system. The pilot enters the flight route, example Frankfurt to Mumbai, tells when so this system tells when it needs to turn and where to go and what speed he needs to fly. Again, Tails is a very important company and Honeywell as well. So navigation and guidance systems. So this uses GPS to navigate and helps the autopilot to where it needs to go. And this also gives distractions and warns if planes are on wrong track. Number four is the health maintenance and monitoring system. So checks if the engines are if the engines are good and the brakes are working in the fuel system, and even checks if the plane is flying correctly. So this warns the engineers if the plane is not working correctly, and to the computers and the engineers even while it's flying. So the companies that provide this called GB Aviation and Airbus Skybase with Palantir and Microsoft Azure. So cabin management system. This controls the lighting and the temperature, how much it needs to be, and so yeah. So this has a screen where the cabin crew will be able to adjust it. So the vendors are Airbus itself and the Lufthansa Systems, and also called Collins Aerospace. The communication systems, this is called ATC and air traffic controls, where they can discuss and talk with other people from the ground or even in the skies. So there's also called the cockpit communication and the ACRS. So how do they do it? Well, they want to send something to the ground. They say it, and then what they said, they will go as radiomagnetic waves in the sky, and then these will be catched by antennas so they can hear what they were saying. But same as ACRS. But if they are on an ocean, if the plane is on an ocean, so then what the pilots were recording, this goes to the satellites, and from the satellites to the antennas where it needs to be. For example, the vendors are Honeywell and Collins Aerospace. And now coming to the cockpit overview. So here I've labeled everything. So A is called the onboard system, onboard information system. This displays essential information such as airport charts and performance details. So the primary flight and navigation display. This contains the primary instrument successfully to operate and navigate a map. And number C is the engine and system display. This can display the engine and how the system is and the status of the system. D coming to the interguard standby instrument system. So this provides a backup navigation system if other systems fail. Multifunction display displays a field flight plan with waypoint details. And F is the throttle control levers. This gives power to the engines. And G is called the radio management panel, like I said, how they discuss. So this displays your current turned ATC frequency so you can discuss with the people on the ground or even on the skies. So H is called the flaps control lever. This displays current flap position and changes flap angle. So here you can see A, B, C, D, and E, and F. So now EI is the Electronic Flight Instrument System, called EFIS. This panel allows you to select different displays on the PFD and MFD. So the PFD and MFD, which I'm going to tell you soon, and as you can see, this is how it looks like. It has two sides because there are two pilots, so they can both see. So J is called the auto flight system control panel. So this is the autopilot system which the pilots don't need to control, and this does it automatically. So J is this. Yeah. So what is the PFD and MFD? Well, PFD is called primary flight display. This shows the altitude and the airspeed and the altitude, heading, and the vertical speed. And the MFD shows the maps with aircraft routes, waypoints, and airports, and also the fuel levels. Now coming to the safety system. So passenger and oxygen masks. So when do they drop? If the cabin loses pressure, oxygen masks drop from above your seat automatically. You'll pull it towards you and place it over your nose and mouth and you can breathe normally. So there are pressure sensors in the aircraft if the cabin air pressure suddenly gets too low. Like the sensors send a signal to open the panels above your seat. Then the masks drop down automatically without you needing to press a button. So how can we breathe from these masks? Well, there's a generator which uses a chemical formula called sodium chloride, breaks down into sodium chloride and oxygen gas. The table salt, which is sodium chloride, stays in the generator and you breathe the gas. So this can last up to 12 to 15 minutes, which is long enough to descend the plane. And the life jackets are usually underneath your seat if you're in a water landing. Emergency exits and lights. Well, these are the emergency doors and the lights which you can see on the ground. Fire alarms and smoke detectors. These are usually in the toilets and also on the plane to detect smoke. This passenger comfort, I'll be skipping it because it's not very interesting. Because next we're coming to the black box. Now the black box. What is a black box? Well, a black box in a plane is actually two devices that record important flight data and cockpit sounds. These devices help investigators understand what happened during the flight, especially if something goes wrong. Despite the name, the black box is actually orange for better visibility after an accident. So the two main types are the FDR, called the Flight Data Recorder, and CVR, the Cockpit Voice Recorder. So what does a black box do? The black box records and stores information during the flight, such as how the plane was flying, what the pilot was saying and hearing, alerts, warnings, and engine sounds, movements like sudden drops, turbulence, or even tilting. So if a crash or accidents happen, the black box gives clues to find out why. So, and how does it work? Let's break it down step by step. Step 1. Continuous recording. The black box automatics recordings data during a flight. So it uses sensors in the airplane to collect information. So this includes engine performance, altitude, speed, and much more. It updates data several times per second, very fast and very accurate. Now step 2 is cockpit recording. Microphones in the cockpit recording. So pilot conversation, air traffic control messages, sounds like alarms or engine noises. This data is stored on a loop, like a repeating tape, and overwrites older data. The CVRs stores last 2 hours data, and the FDR stores the last 25 above data. Storage in crash-proof memory. So all this information is saved on a memory chip inside a protective shell. Even if a plane crashes, the data usually survives. So in a crash, there's a small device called a pinger that sends out pinch signals underwater. It helps to rescue and find the black box ocean, river, or lakes. Once found, the black box is sent to download the data in a lab and study what the cause of the accident was. So what's inside a black box? Well, here's what's usually inside a black box. Memory chips, this is what stores all the data, what happens in the flights. The battery, this powers the pinger and it can last up to 30 days. The insulation, this protects from heat and shock. The protective case, it's made out of titanium or steel so it doesn't burn and it can be safe. The Pinger beacon, this is the beacon that sends out the ping signals underwater. And now coming to how strong a black box actually is. The black box are designed to survive almost anything. Like fire, it can hold up to 1,100 degrees Celsius for 1 hour, and it can also last 6,000 meters underwater for 30 days, and also it can hold crushing pressure for like about 2,000 to 250 kilograms of force. So even after a terrible crash, there are high chances that a black box might survive. So what happens after a crash? Rescue teams search for Pinger signals. Once found, the black box is carefully recovered. Specialists in a lab download this data, so they analyze what the pilot said, what the plane was doing, any warning sounds or sudden movements. A report is written and explain what was the cause of the crash. So where is the black box actually located? The black box is usually located in the tail of the airplane because the tail section is more likely to survive a crash than in the front. So placing the black box gives it better chance to survive than staying in the front. So cool facts about the black box. The first black box was invented in 1953 by Australian scientist called Dr. David Warren, and the tallest group, France, makes black box for Airbus and aircraft. So the cargo and luggage system. So the A350 has two main cargos, a forward hold and the after hold. There are also special bulk cargos for pets or odd-shaped instruments, for example. So per passenger, they give 23 kilograms of bag, and in business, they might usually allow 32 kilograms. A flight can handle 68 tons, including passengers, baggage, and also cargo. The balance of weight during takeoff. So the cargo must be carefully placed because this must be balanced or else this could cause problems. So computers collect information about the weight of the cargo and the number of containers, passenger bags, and also fuel, etc. They calculate the balance and make sure that the plane is not too heavy in the front or in the back, so the balance can stay. So then the special cargo handling for pets. Pets go in a pressurized temperature controlled area in the cargo hold. Musical instruments or fragile items, they stay in hard cases or even in smaller cabins. So the final delivery to airlines. They paint the logo, then they usually have a small delivery ceremony and flight to airlines countries. The first flight will be to its home country. From there, it'll start flying to different countries for real. Now coming to another interesting topic called the MRO, maintenance, repair, and overhaul. This is a process keeping airplanes safe and working all well. It includes regular checks, fixing problems, and even updating some parts. It is a responsibility of the airlines and not Airbus to take care of its flight from the MRO. Airlines either do this work themselves or they have own maintenance teams for their specialized MRO service providers. Some manufacturers like Airbus also offer after-sales support and MRO service. And MRO is shared effort between airlines and MRO companies to keep flights safe and reliable. Example, Lufthansa Technik, it's in Germany, one of the largest global MRO providers in the world. And of course, Air India also has their own MRO system, and so does Emirates. Now the after-sale support. There are maintenance schedule like the daily checks, quick inspections per day. They just check the fuel levels, tires, and the brakes. And the weekly checks, more the review of the important parts like the engines and the control system. And then the yearly checks, these are the checks they do a very high checks of the plane. And then the spare parts and availability, Airbus also offers spare parts if one part gets damaged. For example, software updates and pilot training by Airbus itself, because if Airbus makes any updates so it can train the pilots. Now, last but not least, the 16th point is fun facts. So, how do people get oxygen on a plane? And where does the carbon dioxide go? Well, the oxygen is in pressurized cabins. Airplanes fly at very high altitude, where the air is too thin for humans to breathe. This is called bleed air. To solve this problem, airplanes have pressurized cabins that keep their air inside pressure, similar to what they experience about 6,000 to 8,000 feet above sea level. This is good enough for humans to breathe. This makes sure there's enough oxygen for passengers. So how does it work? Well, the air inside the cabin isn't just recycled stale air. Planes bring the fresh air from outside, usually cooling it down and then compressing it, and then they mix it with the carbon dioxide which is inside, which will be good enough for humans to breathe. And the carbon dioxide, like I just said, it'll be mixed with the oxygen from the outside, and it'll also sometimes when it's too much, it outflows from the engines to the outside to the turbines, and then continues to air refresh. So number two is the Airbus peers list. Well, number one is Boeing. USA, they have major products like 737 and 787, their biggest product there is. Number two company is called Embraer. This is from Brazil. They have E-Jet series, like the E2 series or the E1 series. And their number three is the Bombardier from Canada. This is CRG service and like Q4. Number four is Comac from China. They create a product like the ARJ21 or C919. And the Mitsubishi aircraft from Japan, they create SpaceJet, so formerly MRJ. So number six is Iraq from Russia. They create MC21s. ADR from France or Italy. They create ATR 42 and ATR 72. So number seven is De Havilland Canada from Canada again, called Dash 8400 they create. And number nine, the United Aircraft Corporation from Russia. This Sukhoi Superjet 100 is what they create. So here you'll find a small summary, and thank you for listening to my presentation. And please share your feedback in the comments, and please tell me what I can do next to improve. And please also tell me what I need to do next for the next topic. Like and subscribe, and keep encouraging me what to do next.